Hello everyone, welcome back to this series of tutorials on C++. I am Deepak Kunyal and here I am going to discuss about algorithms of STL. So in our previous tutorial we completed our first part of the containers and we discussed that we have three kind of containers. One is sequence containers, another is associative or non-linear container which is basically divided into two parts. One is sorted and another is non-sorted. And the third container we discussed was container adapters. We also discussed that the first two kind of containers, one is sequence and another is non-linear container, are collectively known as first class containers. So it was all about containers in first tutorial. And another template that we discussed there was part of utility header file and that was pair, right? So now let's proceed and discuss about algorithms. STL algorithms can be used generically across a variety of containers. It provides many algorithms you will use frequently to manipulate containers. The algorithms operate on container elements only indirectly through iterators, which you can consider like a loop iterating over a data. We are going to discuss it right after we finish the discussion on algorithms. So, many algorithms operate on sequence of elements defined by pair of iterators, one pointing to the first element of the sequence and one pointing to the one element past the last element. Also, it's possible to create your new algorithms that operate in a similar fashion so that they can be used with the STL containers and iterators. So we can say that STL is extensible, where it's straightforward to add new algorithms and to do so without changes to the STL containers. So in simple terms, we can say that we have some containers like arrays or vectors or maybe maps or stacks, right? And then we have some iterators like loops which can iterate over these containers, and if you want to perform some operations over them you need some kind of algorithms, right? So these are three parts of the STL library. So these things are called containers, these are called iterators, and you already know that these are called algorithms. And you can use these kind of algorithms on either one of the container or many of the containers, right? But one thing to note down here is that these algorithms operate on all of these containers, but they operate on these containers indirectly through these loops, or we can say iterators, right? There are many algorithms which operate on sequence of elements that are defined by pair of iterators, and one is pointing to the first element of the sequence and another is pointing to the element past the last element. And what does it mean? That we have something like this. Suppose we have this container and algorithm operate on sequence of elements defined by these pair of iterators. One is this and another is somewhere here, which is next to the last element. So this is how some of the algorithms operate. So one thing that is important here is that we are using iterator to operate on these containers. So basically these algorithms are not directly operating on these containers, and that's why it's easier to create your new algorithms and use these iterators and operate on these containers. So it is independent of the container that we are operating because we are basically using iterators. Clear? So we don't need to change any of these and we can make our own algorithms, use iterators and operate on these containers. Clear? So basically there are two kind of algorithms. One is non-modifying sequence algorithms and another is mutating sequence modifying algorithms. So let's first discuss about non-modifying sequence algorithms. So basically non-modifying sequence algorithms are those algorithms that don't result in modification of the containers to which algorithms are applied. So let's discuss some of these algorithms. First algorithm here is count algorithm. We need to pass first, last and value here. So it's going to return the number of elements in the given range that are equal to the given value. So it's just going to count the value in the range and not going to change this container. Another algorithm in this series is equal. It compares the element in two ranges. If all the elements in one range compares equal to their corresponding element in another range, it will return true, otherwise it will return false. So what it exactly means, this function is written something like this: equal, then we have first iterator and last iterator, and these two iterators belong to container 1, and then there is first iterator. Actually you can write first 2 here, and this iterator belong to C2, means container 2. So what it exactly means, it's basically you can say this is vector 1 and this is vector 2. I can write v1 here and v2 here. So it's basically b1 and it's v2. And when we have this first and last, it could be first and last of this vector, which is v1, and then we could have another vector which could have more elements, but this first is beginning from here maybe, and it has 5 elements at this moment. So 1 2 3 4 and 5. So we have to check corresponding element. This element will be checked to this element, so I can mark it like 1 and 1. Then the second element should be checked to this second element, third one to the third element, fourth, and this fifth to this fourth and fifth. And if all these elements are equal, then this equal function is going to return true. Otherwise, this function is going to return false. Otherwise means if any of these elements are not equal, then this will return false, right? So I hope now you are aware about this function equal. Clear? But this is not going to modify the sequence. Then there is another algorithm named search. So it basically searches for a subsequence of element within a sequence of element. And what does it mean? Suppose we have a sequence of element here, and it could have more number of elements. Then we could have another container, and you might pick a range of elements from here, maybe this, and you can call this subsequence because it's smaller, and you can call this as sequence, maybe beginning from here to this place. So search function will search for this subsequence of elements within a sequence of elements, and if this subsequence is found here in this container, it will return a forward iterator that indicate the first element of that subsequence. So it means if this range is found somewhere here, so this is going to return this iterator, which will be forward iterator, right? Forward iterator means it's going to move in the forward direction. Clear? So this will return a forward iterator which will indicate the first element of that subsequence. And if there are no matches, the iterator is positioned at the end of the sequence to be searched. So it means we are going to search from this position to this position, and iterator will be at this place. It means nothing found. Clear? Similarly, there is another function which is search n. So it's a minor difference here, which is search n. So this is going to search a sequence of elements. It means similar sequence, and it is looking for a subsequence in which the value of the specified number of elements have a particular value. And if such a subsequence is found, it will return a forward iterator and indicate the first element of that subsequence. But if there are no matches, the iterator is positioned at the end of the sequence to be searched. So everything is similar, right? One thing that is different here is that the subsequence is going to find in sequence in which specified number of elements have a particular value which we are going to pass here. Clear? Now we have some more functions in this category, and one of the function is find, and here we are going to pass some iterators like first, last, and value. And what this algorithm is going to do, it is going to find the element in given range of number. So you could have a range something like this, and it will return an iterator to the first element in the range, first to last, that compares equal to value this. Clear? and if no such element is found, this function will return last. Clear? So basically this function is a simple function and it's trying to find out this value in this range from first to last. Now there is another function, and this function is mismatch function, or you can say mismatch algorithm. It's going to return a pair of iterator where first iterator of the pair point to the element in the first container and second iterator point to the element in the second container where mismatch has occurred. So it means suppose we have a container here and we have another container at this place. So this function is going to return two iterators, maybe one is I1 and another is I2. So suppose this is I1 and this is I2. It means this is the place where mismatch occurred, right? So as we have talked about all these algorithms, let's talk about one very important algorithm, and this algorithm is used lot much than other algorithms, and this is searching algorithms. So basically when we talk about searching, we have either linear search or binary search, but binary search is more effective than linear search, and it's widely used searching algorithm that require array to be sorted before searching is applied. So it means array should be sorted first. Clear? So the main idea behind this algorithm is to keep dividing the array or maybe vector into half. So divide and conquer approach will work here, and it will keep on going until the element is found or all the elements are exhausted. So suppose you have something like this. So how can you understand this algorithms in an easy way? What you have to do, you have to just take some elements here. We need to sort them, so I am taking sorted values. So maybe we have 1 3 5 7 9 11 15 17 and 19, and suppose I want to find out 3 here. So what we are going to do, we are going to just find out the middle value here and check if this 3 exists on the left side of the array or right side of the array. And on this basis we are going to divide this array into two parts. So these are two parts. We know that this is not the value that we are going to find out, and it's on left because it's smaller than this 9. So we'll discard this whole array and start searching on this portion. Now we have these four elements, and suppose the next value that we find here is this 5. Now again we are going to check whether the value that we are going to find out is equal to this or not. If it is not equal to that, we are going to search on the left side, and then we are going to again discard this right side value and also discard this value because this is not equal to this, and then we have these two values only. Right, again we will divide this array and we'll come to this point, and now as we are here we'll see that the value we are going to find out is this one. So we have found the value, right? So that's how binary search work. So let's see how we can implement it in STL. First thing that we have to do is include algorithm, and then we can use binary search. So function for using binary search is binary, then underscore search. Then we have to write start address here, then end address, and finally the value that we want to find out. So this is the syntax of binary search. Now let's see using some programs how can we implement this. Now let's take an array. So the array could be like this: int a. It's a simple array that we already know from our previous experiences. So this array has these 6 elements. First we have to find out the size of this whole array. So you have a size of operator. First of all you can use size of on a, and then you can use size of and one element, and now this is going to provide you the value 6 in this case. Basically it is going to provide you the number of elements in the array, and the first task that you have to perform is sorting the array. So sorting function is similar to this. You have to put start address and end address. So start address is a name of the array point to the first value, or you can say it gives us the first address, and last address is a plus size, which we have found from here. Now the array is sorted. Now you can use if and else condition to check if value is found or not. So you can use binary search function a plus size, and if you want to find out value 2, so you can do something like this. And if this value is true, it means value is found, so you can print out found here. Otherwise you have to print that value not found, and that's it. That's how you implement binary search in STL. So I hope now you could understand that it's so easy to use these functions in STL, right? So this was all about algorithms first part, which is non-modifying sequence algorithms, and I hope you are well aware of these things now. Although we can discuss a lot of things here, but I think it's enough for this lecture. In the next lecture, we are going to discuss about another part, which is mutating sequence or modifying algorithms, and after that we will talk about iterators in STL. So I think it's enough for this lecture. If you have any doubt or query regarding any of these things, you can write your queries in the comments and I will try to respond back as soon as possible. So guys, see you in the next video. Till then, thank you so much.